So here we go with example 9 from chapter 1.3 on the A2 Pure course. And as usual, first thing we should do really is read the question. Given that 6x squared plus 5x minus 2 over x minus 1, 2x plus 1 is identical, and we check that the denominators are the same, and then find the values of the constants. So it's not said write as partial fractions this time, it's just said find A, B and C. So in one sense, this is easier, but in terms of the maths we've got to do, it's actually a little bit harder, and I'm sure you've spotted why. Because this time we've actually got 3 denominators. So when we multiply through by x minus 1, 2x plus 1, we're going to get 6x squared plus 5x minus 2 is identical to, so on the first one, the x's will cancel, if you like, to leave a lots of x minus 1, 2x plus 1. On the second one, so we've sort of, if you like, cancelled off that. In the second one, we're going to cancel off the x minus 1. So we're going to have plus b lots of x, 2x plus 1. And then the third one, we're going to cancel off the 2x plus 1. So we're going to have plus c lots of x times x minus 1. Okay, now we've got our range of choices here. We could go down our route of picking values of x, or looking at coefficients, or a mix and match kind of approach. Generally, it's easiest to pick values of x at the start if that works. So I'm going to focus on, to start with, on this x here and this x here. And by making that x equal to 0, I'm able to eliminate both b and c. So we get 6 lots of 0 squared plus 5 lots of 0 minus 2 is identical to a lots of 0 minus 1 times 2 lots of 0 plus 1 plus, and then I would never bother to write this out normally, b 0, 2 lots of 0 plus 1 plus c times 0 and 0 minus 1. But you can see these terms are going to be equal to 0. So we tend not to write them out. Well, what does that leave us with here? Negative 2 on the left is equal to negative 1 times plus 1. That's what we've got left in here, isn't it? Negative 1 times plus 1 is going to be minus 1. So negative a implies a equals 2. Okay, can you see another good value to choose? Okay, well, I am going to look in and I'm going to focus in now at the x minus 1 brackets, because again, I can pick a nice whole number for x and eliminate both the a and the c. So we let x equal 1. So we get 6 lots of 1 squared plus 5 lots of 1 minus 2 is equal to, the first term is going to vanish with a in, then we've got b lots of 1 times 2 lots of 1 plus 1, and the c term is going to vanish. So we get 6 plus 5 is 11 minus 2 is 9 equals 1 times 3 is 3b implies b equals 3. Okay, now we could look at eliminating both a and b using a similar technique. So we could let x equal -1/2, but putting loads of fractions in and stuff like that might cause problems. So instead, I tend to prefer to look at either my units, my coefficients of x, or my coefficient of x squared. And my advice is look at the extremes. Look at extremes. In this case, that's either the units or coefficients of x squared. So, what will we get if we do that? Let's pick one to look at. The units don't look too bad. If we lift out the units, what do we get? So we look at the units. We've got -2. Yeah, so by the units, yeah, we're looking at this bit here. Yeah, -2, and a times -1 times +1. So that will give us negative a, because -1 times +1 is -1. -1 times a is -a. Then the units on the next, well, there are no units on the next. So actually by looking at units, because you've got x times 1, so that's got no units, and cx times -1 is -x. So that's, the units haven't given us a solution, and we've already got a equals 2, so that's the same answer. So let's look at the coefficients of x squared and see what that does. 6 is equal to, so the coefficients of x squared, running out of colours up here a little bit. Let's try that. Hopefully that's not too dark. Yeah, that's okay. So 6 lots of x squared. Here we've got x and 2x, so that's 2ax squared. So it's just 2a plus 2b, using the same idea. b, x and 2x gives 2x squared, 2bx squared. So plus 2b. And now we come to the last bit, c's, which will be cx times x, so cx squared, so plus a c. Okay, now that looks like one equation with 3 unknowns, but we've already worked out a and b. So we've got 6, substitute in for a, 2 lots of 2, plus b, which is 2 lots of 3, plus c. So 6 equals 4 plus 6 plus c, implies c equals -4. So a is 2, b is 3, c equals -4, and you might want to list those at the end carefully. Therefore a equals 2, b is equal to 3, and c equals -4. Just to make your answer nice and clear. I'm not saying that's necessarily the best approach on this question, but what I want you to understand is that there is a combination. So it's not like you can use one approach or the other approach. You can mix and match within any question, because both techniques and both methods work all the time. Okay, I hope that's clear. Here's a few questions to have a go at. So, the work I'd like you to do is from page 11, exercise 11, sorry, not 11, exercise 1D, questions 2, 3, 4, 5, 6 and 7. 2, 3, 4, 5, 6 and 7, and if you really don't feel like that's enough practice, you can always go back and do question 1 for fun.